Okay, so now we're going to talk about atomic number and mass number. Let's start with atomic number. Atomic number is the number of protons in an atom of that element. So if an element has 6 protons, or an atom has 6 protons, it will be carbon. That's how we decide what kind of an element it is. You'll find the atomic number on the periodic table right above the element symbol. So for calcium here, it's 20. We want to fill out this table. We would see that nitrogen is here. It has the number 7 above it. That's its atomic number. The number of protons is going to be equal to the atomic number via the definition there. So we have 7 protons. Now we can figure out the number of electrons as well, because the protons, each one has 1 positive charge, and each electron has 1 negative charge. So if we have 7 positive charges, we must have 7 negative charges, or else we'd have a charged atom. So let's look at zinc next. Zinc is here. It has a 30 above it, so that's its atomic number. It's also the number of protons that it has. It has an equal number of protons and electrons, otherwise we'd have a charge over here. Sulfur is here. It's number 16. 16 is its atomic number. 16 is the number of protons, and 16 is the number of electrons in that atom. Okay, so the mass number is equal to the number of particles in the nucleus of that particular atom or isotope. It's equal to the number of protons plus the number of neutrons. The isotopes of particular types of atoms can be written 3 different ways, and I've written it out for chlorine-35. Chlorine-35, chlorine is the name of the element, and 35 is the mass number. Cl is the symbol for chlorine, so Cl35 refers to the same element. And here we have chlorine, and it's got these 2 numbers. The mass number is here, and this is the atomic number. Or the number of protons. So let's look at this table and see if we can fill it out. So we start with the chlorine-35. The mass number is given right behind the chlorine. It's 35, right? It's this number right here. The atomic number, we're going to need to use this periodic table. And chlorine is right here. It has a 17 written above it, so that's an atomic number of 17. The number of protons is going to equal the atomic number, so that'll also be 17. The number of neutrons, well, we have the mass number and we have the number of protons, so we should be able to figure out the number of neutrons is equal to the difference in these 2 numbers. Okay, so the mass number is protons plus neutrons. The number of neutrons here is going to be equal to, in this particular case, the mass number minus the protons. And 35 minus 17 gives us 18. Right, for the next one, they've not told us what element this is. I'm going to need to pull in another periodic table that has more elements on it. I had them cut off. Okay. But we have an atomic number of 80. So we can look on the periodic table and see that 80 is mercury here. And if it has 80, if the atomic number is 80, the number of protons is also 80. They've given us the number of neutrons, but not the mass number. But we can add the number of protons and neutrons together to get the mass number, which is 197. Protons plus neutrons to get 197. And this will be mercury 197. So here they've given us a mass number. They haven't given us the atomic number, but we have the number of protons, so we know the atomic number must be 53. These two numbers are always going to match up. We can look on our periodic table and find 53, and it's iodine. We're given the mass number, so we'll just go ahead and write that down. Iodine 125. The number of neutrons is going to be equal to the mass number minus the number of protons. And that's going to be, we'll take the mass number 125 minus number of protons 53, and that gives us 72. And lastly, I've got carbon 14. You can stop the video and see how you do on this one. All right, hopefully you got it right. Okay, so we got 14, carbon 14. The mass number is given to us right here. It's 14. The atomic number, well, carbon is here. So the atomic number is 6. Number of protons is equal to the atomic number. And then the mass number will be 14 minus 6, or 8. So given the atomic symbols to determine the number of protons, neutrons, and electrons. Well, let's not do all of these. Let's just do this oxygen here. This is the atomic number. And this is the mass number. So the number of protons is going to be equal to the atomic number, so that's 8. Since the atom here is neutral, it'll have to have the same number of electrons. So it'll also have 8. The number of neutrons is going to be equal to the mass number minus the number of protons. So 16 minus 8 will give us 8. So it's 8, 8, 8.